Okay, we're now to the point of doing the full stoichiometry, all right? Stoichiometry is dealing with ratios of reactants to products. So anytime you're asked a question about, oh, if I had so much of this, how much of that can be made, that's stoichiometry right there in a nutshell. It's the quantities of reactants to the quantities of products, all right? One of these, if we're given 10 grams, let's say, of silver nitrate, that's just given to us. We're saying, what if you had 10 grams of silver nitrate? And if we had 10 grams of table salt, NaCl, here's the test question, or a question that you'd be likely to see on a test. In this balanced reaction, and this reaction's already balanced, it's a 1 on 1 on 1, 1 on 1 on 1 on 1 ratio of all the compounds. All right, and for this balanced reaction, what is our limiting reagent? All right, and by now we should know the limiting reagent is the thing that runs out first in a reaction. It's the reagent or the reactant that runs out first. Does this run out first or does that run out first? Don't assume that, oh, what if that were only 5 grams? Oh, it must be the one with the least amount of original reactant. No, you can't go by the limiting reagent. It might be the thing that you've got the most of in terms of grams, but it could be the chemical that runs out first. However many reactants you have, that's how many times you have to go through stoichiometry. So that means this problem, I'm going to do 2 reactions, and whichever one produces the least amount of product, that's going to be the limiting reagent. All right? Take it to one of your products. It doesn't matter which one you pick. I'm going to pick this one just so I don't have to deal with subscripts, and there's only 2 elements in it. So I'm going to take it to silver chloride. So whichever one of these reactants produces the least amount of silver chloride, that's going to be the limiting reagent. Here's how we're going to do it. For both equations that we're going to write down, I start with the given, just like we've always done. So I'm going to do this one first. I'm going to say, oh, what if I had 10 grams of silver nitrate? So the first step is to write down your given. All right, and then in a minute, we're going to have to do this again with sodium chloride. But right now, we're just going to focus on the first reagent, okay? Change grams into moles. Change grams into moles. Well, how do we do that? We take the total atomic mass. We have to add up 1 silver, 1 nitrogen, and 3 oxygens. So silver has a mass on the periodic table of 108. So we'll say 108 plus nitrogen is 14 plus oxygen is 16, but we have 3 of them. So we got to do the total mass. It's 170. All right. So this step we actually converted to moles. So convert to moles. Okay. That's the second step for a limiting reagent problem. We convert whatever we start with in grams, we convert it to moles. Okay? Now the next step is really important. All of them are important, but this one is crucial. We've got to do a mole to mole ratio based on the coefficients in the balanced equation. So if I'm going to take it here to silver chloride, and I'm looking at silver nitrate first, I have a 1 mole of silver nitrate to 1 mole of silver chloride ratio. It's just a 1 on 1. So I'm going to cancel out my like units. I'm going to put 1 mole of silver nitrate on the bottom and 1 mole of silver chloride on the top. And then cancel out that. Just be careful, make sure you write silver nitrate on the bottom because you have to be able to cancel numerator to denominator. All right, so this step is what we call a mole-to-mole ratio. Mole-to-mole ratio. This whole process, it may be tedious, but it's not all that difficult once you get the hang of it. You do several practice problems. It's just a lot of steps. Now our last step is we want to convert moles of silver chloride back to grams of silver chloride. So how do we do that? We add up silver, the mass of silver. We add up the mass of chlorine. All right, we look at the periodic table. 108 plus 35, and it's 143 grams. All right, now this last step, what did we do? We just convert back to grams. Convert back to grams. Okay? All right, so when we convert back to grams, we should be able to answer the question now. Multiply all the numerator out. So if I multiply 143 by 10, I get 1,430. Now, this all happens to be over the number 170. So 170. So all I did was I just did a product of the numerator, a product of the denominator. All right, and to get the final answer, you just divide the numerator divided by the denominator, and I'm getting 8.4 grams of silver chloride. Okay? All right, we did all of that for the first reagent. We said if we're given 10 grams to start with, how much silver chloride can we make? If there's another reagent, we got to do it one more time because we got to determine which reactant makes the least amount of product, and that would be our limiting reagent. So how many grams of salt did we start with? That was our given, 10 grams of salt, table salt. Now we got to change, the next one, we got to change grams to moles. How do we know the molar, how many grams are in 1 mole? We take the molar mass. 23 plus, sodium is 23, plus 35 should be 58 grams. Okay? You got to write out everything. Don't take any shortcuts. All right, the next step is going to be a mole to mole ratio. Remember, we're going to the sodium chloride. You got to go to the same product each time. All right. This equation balance happens to be a 1:1:1:1 ratio, so it's just going to be 1 mole of salt to 1 mole of silver chloride, and cancel it out. Now, the nice thing about these is that last step is always going to be the same. They're going to be identical. I change 1 mole of silver chloride back to grams. Okay, and it's 143 grams. Cancel, cancel. All right, and again, just multiply all the numerator and get an answer. 10 times 143, that's still going to be 1430. Over this time, over 58. So 1430 divided by 58, and I'm getting 24.7 grams of sodium chloride. So, what does all that tell us? That tells us that only 8 grams can be made if I'm starting out with 10 grams of silver nitrate. I'm only going to be able to make 8 grams of my product. So my limiting reagent is the silver nitrate. That's my limiting reagent. The chemical that you have more than enough of, all right, is this one, and it's said to be in excess, which is just the way the chemists say in excess. You just got more than you ever are going to need, so it's in excess. All right, so the one that's in excess is the one that you got the most product. The one that made the reagent that makes the least amount of product, that's your limiting reagent. Okay, so if you go back and look, even though it may look like a bunch of steps and a bunch of stuff, it's really not difficult if you keep the big picture. You write down the given for each reagent. Write the given. Given is 10 grams for this one, 10 grams for that one. It could have been 2 grams and 20 grams, or 50 grams and 1,000 grams. So whatever's in the problem being given, you write that down first for each reagent, okay? Then we convert the grams to moles. Well, how did we do that with dimensional analysis? we took the molar mass and put it on the bottom to 1 mole on top, right? Because that's how you always say how many grams are in a mole. The next step is super important because in chemistry, everything is based on ratios, all right? We just happen to have an equation where all the coefficients were a 1, but you know how some balance equations, the coefficient may be a 2 to 3 to 8 to 20 ratio. So you gotta look at your big number out front for the mole to mole ratio. It's like saying, oh, to make a car, you gotta have 4 wheels and 1 body frame. All right, to make a bicycle, you gotta have 2 wheels and a body frame. Everything is based on ratios, okay? Then the final last step is to change the product back from moles back into grams. Again, how do you do that? It's the molar mass, okay? We look at the periodic table, we add up 1 silver, 1 chlorine, and get the molar mass. So use this as a guide for any and all of your stoichiometry problems, especially if it's asking you to find the limiting reagent. Just remember the reagent, or reactant in other words, for its reactant. The reactant that produces the least amount of product, that would be called your limiting. That's going to run out first. That's your limiting reagent. All right? And the one that you have more than enough of, in this case, sodium chloride, that would be said to be in excess. It's excessive. You got more than you're ever going to need. And that's stoichiometry.